In this video, we're going to start looking at motion in 2 dimensions. So that means we're looking at 2 vectors and vector addition, basically. And we're not going to worry about 3-dimension motion because that just starts getting a little tricky. So what you are going to need for this, because we are doing scale diagram method here in this video, you're going to need a ruler and a protractor. Those are going to be the tools you need to solve these problems. Before we look at an actual problem, let's just review the compass rose, because we're going to have to indicate our direction, because it's not going to be due north, due east, due west, or due south. We're going to be involving angles. So if we look at this first figure, figure 2, sorry, it's showing a vector that's pointing due east. That doesn't happen very often. And so if you look at figure 3, we have a vector direction. And so what we say is that it's east, because it's going east, and then it's rotated 20 degrees towards north. And so you can see that this is how we indicate that. East, 20 degrees north. So that means we'd start going due east, but then we want to go 20 degrees towards north. Okay, that's obviously more than 20 degrees, but you get the idea. So that's how we're going to indicate our direction. So we're always going to be looking at horizontal components, which I'm going to call like my dx values, and our dy values. Okay, so when we're looking at things, we're going to be looking at horizontal dx and vertical dy components. So let's look at this example. So we have a runner that's running 60 meters east and then 85 meters south. What is her total displacement? So what you're going to do is you're going to create a scale. And I would say you're using a ruler. It's got centimeters on it. So I would say you've got 1 centimeter equals 10 meters. So then obviously these are going to take up quite a bit of space on your piece of paper. I'm going to use grid paper just because it's going to be hard for me to show you using a ruler on this video, just the way it works. So I'm going to choose my starting point as being here. And I'm going to count over 6 blocks. So count over 6, or for you, you would be measuring exactly 6 meters or 6 centimeters going in the east direction. So we'd put that arrow heading in the east direction. Then we're going to count, or you're going to use 8.5 centimeters in the south direction. I'm going to use 8.5 blocks. So again, you need to use a ruler when doing these calculations or these problems. And then using your ruler, you're going to connect from your tip to your tail. So that was terrible on my part. But if you were actually using a ruler, it would be a lot easier. So you're always going to start from your starting point to your end point and connect it with an arrowhead. And then what you would do is you would be using your ruler and you would measure. Now, I have actually drawn this out on paper, and so I get approximately 10.4 centimeters. Okay, so if I had 10.4 centimeters when I actually measure it out, I would then multiply it. So we'd have to multiply it by 10 because every 1 centimeter is equal to 10 meters. So we actually have 104 meters. Okay, so that would be our displacement. And then because it's not in a due direction, so directly facing one direction, we need to figure out our angle, so our theta. So you're going to go ahead and you're going to use a protractor. So again, I have done this on paper, and so I get 55 degrees approximately. Okay, the thing with a scale diagram is it's never going to be perfect, so as long as you get something close, then you should be okay. So our displacement, so we're going to kind of write a therefore statement, would be 104 meters. And then we are going east, 55 degrees south. Because if you look, we're heading in the east direction, and then we're rotated down. So rotating down is in our south direction. So that's how you would solve that problem. So when you're solving questions using the scale diagram method, there should be absolutely no algebra shown in the work area. Okay, so please do not show any math except for your scale diagram calculations. That's really all you should be showing. There should be no other math. So do not use Pythagorean theorem and do not use your trig ratios to solve these problems. That is what the algebraic method in our next video is all about. So this video was just a quick review of a scale diagram method. Now we looked at one's vectors where they're at right angles, and we can have them where they're not at right angles. So hopefully you can follow along in your textbook. You're doing the same thing. You're going to create a scale, draw your two vectors, connect them tip to tail, and then you need to measure that, convert using your scale, and then use your protractor to determine the angle.